Lesson 2.2 is on solving inequalities by adding or subtracting. So in this lesson, we are going to be solving one-step inequalities, and it's very similar to solving one-step equations. To solve an inequality, you need to isolate the variable using the properties of inequality and inverse operations. So if we have addition, if we're adding the same number to both sides, it'll make the statement still true. So what you do to one side, you do to the other. For subtraction, same thing. If you subtract something from one side, you subtract it to the other. So these are true for inequalities as well as all of our inequality symbols. So greater than or equal to, less than or equal to. So we're going to start by looking at example 1. So first you need to solve the inequality and then you'll graph the solution. So here I have x plus 9 is less than 15, so I'm going to subtract 9 from both sides to isolate x. 9 minus 9 gives me 0, so I'm left with x. And then 15 minus 9 gives me 6. So x is less than 6. And now I go to graph it. So I'm going to draw my number line. So I have 6, 8, 10, and then 4, and 2. So it's less than, so I'm going to have an open dot at my important number, which is 6. Okay, and then 2 and 4 are less than 6, so I'm shading to the left here. And then you draw your arrow. Okay. B, I have D minus 3 is greater than negative 6. So I'm going to add 3 to both sides to get D by itself. Minus 3 plus 3 gives me 0, so I'm left with D. And then I have greater than. Negative 6 plus 3 gives me negative 3. So D is greater than negative 3. Now I'm going to go ahead and graph it. So I have negative 3, negative 2, negative 1, negative 4, negative 5. So I have strictly greater than, so I'm going to have an open dot at negative 3. And then since it's greater than, negative 2 and negative 1 are bigger or greater than negative 3, so I shade to the right. And then I draw my arrow. So that is what your graph would look like for B. C, I have 0.7 is greater than or equal to n minus 0.4. So I'm going to add 0.4 to both sides. Line up your decimals to help you add. 7 plus 4 gives me 11, so I'm going to carry my 1, bring down my decimal. 1 plus 0 is 1. So I have 1.1, and then that's greater than or equal to minus 0.4 plus 0.4 gives me 0. So I'm left with n. Okay, and then we're going to flip our inequality. So we're going to turn n to come first. My inequality changes to go the other direction, and then I have 1.1. So remember, the inequality is still opening to this 1.1 because it's bigger. So we didn't change the value of it. So it reads n is less than or equal to 1.1. So now I'm going to go ahead and graph it. So we have 1.1, 1.2, and then over here 1.0. And then it is less than or equal to, so I'm going to have my dot at 1.1, but it's equal to, so my dot gets filled in. And then n is less than, so I shade to the left here. So I'm shading to the left, and then I'm going to draw my arrow. There are 3 check it out problems for you to try. So go ahead and pause the video and try these 3 on your own, and then resume the video once you are ready to check your solution. So for A, I'm going to subtract 1 from both sides. Plus 1 minus 1 gives me 0, so I'm left with S. And then I have less than or equal to, 10 minus 1 is 9. Now I'm going to go ahead and graph it. So I'm going to put 9 in the middle, 10, and 8. Less than or equal to, so my important number is 9, and it's going to have a closed dot. And then it's less than, so I'm going to shade to the left here. Draw my arrow. B, I have 2.5 is greater than negative 3 plus t. So I'm going to add 3 to both sides. 2.5 plus 3 gives us 5.5. Greater than. Negative 3 plus 3 gives me 0, and then I have t. And then I'm going to flip my inequality. So t is less than 5.5. For my graph, I'm going to put 5.5 in the middle. Oops. 5.5, sorry about that, 5.5, and then 6, 5 over here, so I'm increasing by half. I'm going to have an open dot at 5.5 because it's just less than, and then for here, I shade to the left. Now you might have done your scaling slightly different. As long as your dot is the same, it's open and it's shading to the left, you are fine. Okay. Dot needs to be on the same number. It needs to be open or closed to match these, and then you're shading the same direction. For C, I'm going to add 3.5 to both sides. Minus 3.5 plus 3.5 gives me 0, so I'm left with Q. Less than 5 plus 5 is 0, or 10, sorry, 0, carry my 1, bring down my decimal. 1 plus 7 plus 3 gives me 11. So Q is less than 11. So I'm going to draw my number line. So I have 11, 12, and then 10. I'm going to have an open dot at 11. And Q is less than 11, so I'm shading to the left here. And then I draw my arrow. So those are the solutions for the check it out problem. Just a reminder, since there is an infinite number of solutions to an inequality, it is not possible to check all the solutions. Okay, you can check the endpoint in the direction of the inequality symbol. So the solutions of x plus 9 is less than 15 are given by x is less than 6. So step 1, you can check the endpoint. Okay, make sure you substitute in 6 for x in the related equation, x plus 9 equals 15. The endpoint should be a solution of the equation. So you replaced x with 6, 6 plus 9 is 15, 15 equals 15. Then check the inequality symbol. Substitute a number less than 6 for x in the original inequality. The number you choose should be a solution of the inequality. So if you pick 4, 4 plus 9 gives you 13. Is 13 less than 15? Yes, it is. So that would be a good solution set. So now we're going to look at example 2, problem solving application. So the memory in Tina's camera phone allows her to take up to 20 pictures. Tina has already taken 16 pictures. Write, solve, and graph an inequality to show how many more pictures she can take. So first you're going to understand the problem. So the answer will be an inequality and a graph that shows all the possible pictures she can take. So we know her phone allows to take up to 20. She already has 16 pictures. So can take at most 20 pictures. She's already taken 16. So we're going to say let P represent the remaining number of pictures. So the number taken was 16 plus the remaining is P. Is at most, so less than or equal to 20. We can't go over 20. So now that inequality, we're going to go and solve it. So 16 plus P is less than or equal to 20. I'm going to subtract 16 from both sides. 16 minus 16 gives me 0, so I'm left with P. Less than or equal to 20 minus 16 gives me 4. So P is less than or equal to 4. Now, it's not reasonable for her to take a negative or fractional number of pictures. So, graphing the non-negative integers less than or equal to 4, she could take 0, 1, 2, 3, or 4 pictures. So, you only have a closed dot at 0, 1, 2, 3, or 4. And now, just to make sure it's reasonable, check the endpoint. So, here we had 4. So, 16 plus P equals 20. 16 plus 4 does equal 20, so that sounds good. And then check a number less than 4. So, here we tried 2. 16 plus 2 is 18. Is 18 less than or equal to 20? Yes. So adding, remember only whole numbers, we can't do fractional or negative, 0, 1, 2, 3, or 4 more pictures will not exceed that 20. So now there is a check it out problem. Okay, it says the recommended dietary allowance, RDA, of iron for female in Sarah's age group 14 to 18 years old is 15 milligrams per day. Sarah has consumed 11 milligrams of iron today. Write and solve an inequality to show how many more milligrams of iron Sarah can consume without exceeding the RDA. So pause the video, take a moment to write out the inequality, solve it, and graph it. And then resume when you're ready to check your answer. So the maximum is 15 milligrams per day. She consumed 11. Okay. So we're going to say 11, our inequality is 11 plus x, okay, how much more she can consume, is less than or equal to 15. Because the most she should be consuming is 15. So it can be equal to 15 or less than. So now I'm going to subtract 11 from both sides. 11 minus 11 is 0. So I'm left with x. Less than or equal to 15 minus 11 gives me 4. So x is less than or equal to 4. And then having that on a graph, I had 4. And then above we could have 5 and 6. And then over here, 3, 2, 1. I should have made this just a hair longer. So let me get out my whiteout here. I'm going to make it a little bit bigger. So we have 1 and then 0. Okay. So we can have less than or equal to 4. So we're going to have a closed dot at 4 because it could be equal to. And then it could go to 0. Okay. But it can't go less than 0 because it can't be negative. So anywhere between 0 and 4 would be a solution to this situation. Okay. So here Sarah can consume 4 milligrams or less to meet the RDA's requirement. Now we're going to look at example 3. Josh can bench press 220 pounds. He wants to bench press at least 250 pounds. Write and solve an inequality to determine how many more pounds Josh must lift to reach his goal. Check your answer. So, he can press 220. He wants to press at least 250 pounds. We want to figure out how many more pounds he must lift to reach his goal. So 220 pounds plus the extra is at least 250. So the smallest he wants to be at is 250. So he wants this to be greater than or equal to 250. So 220 plus P for the additional pounds is greater than or equal to 250. So we have 220 plus P greater than or equal to 250. So we're going to subtract 220 from both sides. 220 minus 220 gives us 0. So we're left with P. 250 minus 220 gives us 30. So P is greater than or equal to 30. So Josh must lift at least 30 additional pounds to reach his goal. There's a check it out problem. So Josh has reached his goal of 250 pounds. Now he wants to try and break the school record of 282 pounds. Write and solve an inequality to determine how many more pounds Josh needs to break the school record. Check your answer. So go ahead, pause the video and answer this problem on your own. And then resume when you're ready to check your answer. So he has 250 pounds. The record is 282. So we have 250 plus the additional he needs. This has to be greater than 282. Because if he gets exactly 282, does he break the record? No, he doesn't break the record. He would match the record. We want to break it. So it has to be greater than 282. So now we're going to subtract 250 from both sides to isolate our variable x. 250 minus 250 gives us 0, so I'm left with x is greater than 2 minus 0 gives me 2. 8 minus 5 is 3, and then 2 minus 2 is 0. So x has to be greater than 32. So this means Josh needs to bench press more than 32 additional pounds to break the school record.